In this video, I'm going to demonstrate how this simple DIY motor works. So everybody's played with magnets and know that there's a North Pole and a South Pole. So right now we have the North Pole opposite the South Pole, and so they attract. And likewise, if you flip it around and you have the same poles to each other, then of course it repels. So that is the same principle that we use to build this motor, but let me explain a little bit how that works. If you take a battery and you went from positive to negative, we'll put the positive on the bottom, and you put it through a wire. If your thumb is in the direction of the current, then you would have magnetic field lines that wrap around in the direction of your fingers. Now likewise, if you have a coil and you do the same thing, it will go from positive to negative, but you wrap the wires in the direction of your fingers, then what's going to happen this time is that your thumb is going to point to the magnetic north. And that's an important principle to understand to see how we built this electric motor. Because what we want to do is we want to create a field so that we have a positive and negative attracting each other, pulling the armature together. Let me explain that a little bit further. So if you take a close look at this, you will see 4 coils. So let me take the camera off. So there's a coil here that connects to this piece of metal, and another coil here that connects to this piece of metal. Now the way we did it was we put this in one direction and this one in the opposite direction, so that one would have the North Pole up here and the other one would have the South Pole up here. Now, just like in the demonstration with 2 magnets that are together, the way we achieve torque is to have 2 additional coils on the armature. And then what we wanted to do was when this one is north, we wanted to have this one be south so that it had a force pulling it in this direction. And then likewise over here, you would have it in the opposite direction. And then when it got past center, then what we would do is that we would push. So here we're pulling, and then here we're pushing. So these 2 stay the same, but this one would change. So for example, if this one is north, then we would have this one be north as well, and that would push. So what it does is it pushes and pulls. And the way we've achieved this is through brushes. So here are the homemade brushes. And the brushes, what they do is that they change direction of these coils on the inside. So these stay the same, and then these change at every half revolution. So let me demonstrate that. Okay, so it's plugged in, and then right here, it's got a force right here, and you can feel this pulling, and you can hear it. And if I let it go, then it will swap direction right here and do the same with the other side. Now if we take a paper clip, you can see that each one of these is a magnet, and it stays in the same direction so the paper clip doesn't fall. But what was interesting is that if you put the metal here, I can't demonstrate this on a video, but I can feel it pulsing, and the reason it's pulsing is because of the magnetic field direction of the armature as it comes around. In fact, I can feel that right there. So there's really no way to demonstrate it. But it actually has a fair amount of torque, and I can slow it down, or I can put a load on it with my finger, and it still continues to pull pretty hard. So what I have here is that's a 1/2 amp going through this power supply at, I believe it's 12 volts, but I have to check it out. So that is how a little DC motor works, and I hope you enjoyed this video.